Hi, let's show that the limit as x approaches negative 1 from the positive side. This is a right-hand limit of the function square root of x plus 1 is equal to 0. You can see from the sketch what's going to happen as we approach x equals negative 1 from the right. The y values are getting closer and closer to 0. Formally, we are seeking delta greater than 0 such that for every positive epsilon, a less than x less than a plus delta produces the absolute value of f of x minus L less than epsilon. That's part of the definition for the right-hand limit. Okay, let's go ahead and work this out. Well, for this problem, we have a is equal to negative 1, f of x is the square root of x plus 1, and L is equal to 0. So we're going to restate what we're seeking in the cloud. We're going to restate it with these values. We seek delta greater than 0 such that for every positive epsilon, negative 1 less than x less than negative 1 plus delta produces the absolute value of our function square root of x plus 1 minus our limit 0. In other words, absolute value of the square root of x plus 1 smaller than epsilon. All right, that's what we want to show. All right, so put that in the cloud and let's get to work. Let's make the assumption that negative 1 is less than x is less than the negative 1 plus delta and show the absolute value of the square root of x plus 1 is less than epsilon. Step 1, we're going to start with what we want to prove and then work backwards to find delta like we've been doing. Given any positive epsilon, we seek positive delta such that negative 1 less than x less than negative 1 plus delta implies the absolute value of our function square root of x plus 1 minus 0, the limit, is less than epsilon. Well, f of x minus L, absolute value, is the absolute value of the square root of x plus 1. Well, that's equal to the square root of x plus 1 because square roots are always non-negative. We don't have to have the absolute value bars on it. So these are all equal to each other, no inequalities. These are all equal so far. But that's smaller than the square root of delta because negative 1 less than x less than negative 1 plus delta, if we add 1 to the three regions of this inequality, we get 0 less than x plus 1 less than delta. Thus, we're going to use the square root of delta equals our epsilon to get epsilon at the end. In other words, solving for delta, we get delta equals epsilon squared. All right, so this is because, of course, we want epsilon at the end, not delta, so ignore what I wrote there. It's epsilon at the end is what we're looking for. All right, solving that for delta, we get epsilon squared. We just squared both sides. Step 2, assume that a less than x less than a plus delta and choose epsilon equals epsilon, delta equals epsilon squared. All right, so we're making this assumption, negative 1 less than x less than negative 1 plus epsilon. In other words, 0 less than x plus 1 less than epsilon when I get 0 on the left and x plus 1 in the middle. And let epsilon delta equal epsilon squared with epsilon greater than 0, of course. So then the absolute value difference is equal to the difference between the square root and 0, which is just the absolute value of the square root. Well, that's just the square root because we don't need the absolute values on a positive value. And that's going to be smaller than the square root of delta, which we said is equal to the square root of epsilon squared. Well, that's just equal to epsilon. Normally it would be the absolute value of epsilon, but we already said epsilon's greater than 0, of course. And that's all we need to prove, that the limit as x approaches negative 1 from the positive side of the square root of x plus 1 is equal to 0.